So the next section, 6.2, is called separation of variables. Also deals a little bit with growth and decay, but to this lesson's focus is really going to be on this idea of a variable separation. So we're still talking about differential equations, which means we're still going to be given equations that involve a derivative. But now, instead of looking at them and having them all be in terms of one variable, usually that variable is x, we're going to look at what happens when you have derivative equations that are in terms of x's and y's. So it's kind of like the idea with implicit differentiation. We were trying to derive with a bunch of x's and y's. Well, now we're trying to work backwards and we're trying to integrate, but our x's and y's are jumbled up. So if you look at these two different examples on the front, on the top of the year, you have this dy dx equals 2x over y. So that's really what we're talking about today, is what happens if your derivative is in terms of two variables. So we have to have some way to fix it because we have two variables on the right side, versus what we're used to doing, which we're used to working with a derivative that's all in terms of one variable. Usually it's x, but sometimes we work in terms of t or theta. And those are ready to integrate to start. We have it ready to go. We integrate the function using whatever old rule we've learned, and we get our general solution. So the fix, the way that we deal with this, it's a very algebraic fix, is something called separation of variables. Separation of variables means that we're going to rewrite that differential equation so that each variable only appears on one side. So we'll have our x's on one side and our y's on the other. We're going to use a lot of algebra. Cross multiplying shows up a lot. It's very, very algebraic in its process. So I have the 3 steps written as far as what happens, step 1, step 2, step 3. So step 1 is the separation step. We want to completely rewrite it so that your x's are on one side and your y's are on the other. In addition to your x terms being on that one side, we also need this dx. So we are literally splitting up the dy over dx, thinking of it as a fraction, dy on top, dx on the bottom. So when we split that, our dx needs to go on the side with all the x's, and our dy needs to go on the side with all our y's. So everything is separated, including that dy over dx. Once you have it completely separated, and that may take 1 or 2 steps, you're going to integrate each side separately. When you integrate each side, you can use any technique that we've learned to this point. You can do a U sub, you can do a power rule, you can do a trig integration. You do not expect that both sides will integrate the exact same way. Oftentimes, one side is really easy to integrate and the other side is much more complicated. So you definitely will have kind of that balance between difficult integrals and hard integrals. Once you have that done and you have integrated both sides, your last step is to simplify. There definitely will be times where you have to solve for y. They will actually tell you in the problem, it will ask you to write it as y equals f of x. That is your indication that you have to get y by itself, especially if there's only one y in the entire answer. That's usually when it happens the most. You will need a plus C, and the plus C will go at the very end, and we'll use that and some more information to find particular solutions. So let me take you through one in this intro video and then kind of stop and then make other videos that take you through some more complicated ones. So this is what the problem will look like. The directions will say something like solve for the general solution, or it may give you information and ask you to solve for a particular solution. So first we need to separate. So this one's actually very easy to separate because we can do a cross multiplying. If we multiply diagonally one way, we get y dy. If we multiply diagonally the other way, we get 2x dx. Once you have it separated, which in this case was really quick, you're going to integrate each side. The integral of y is just y squared over 2, just doing a power rule. The integral of 2x is just x squared. You'd have 2x squared over 2, but the 2's would cancel. You only have to put the plus c once because putting a constant on both sides is just, again, creating a single constant. If the directions ask you to get y by itself, you may see more work done. So for example, for this one, you can multiply everything by 2 to get rid of that 2 in the bottom. So we'd have y squared equals 2x squared. We don't have to write 2c. When you multiply a constant by 2, it's still a constant. This may be acceptable, or they might want you to go a step further and solve for y by taking the square root of both sides. Kind of go by the directions, and the directions will let you know how much simplifying is expected. So that is the idea of separating and integrating. This is called a general solution to the differential equation. If I wanted a particular solution, meaning finding the c value, I would have to give you an initial condition or an extra piece of information. So that's the overview. We'll continue with these examples in the next video.